All right, guys, we're going to talk about dimensional analysis. Now, you may have heard that term before. Dimensional analysis is something you use in chemistry. If you've taken chemistry, you use stoichiometry and mole conversions. Um, that's dimensional analysis just applied to like grams and moles and molecular weights and what have you. All right. Beautiful thing about dimensional analysis is you can use it for any units. Now, to use dimensional analysis, you have to have a conversion factor. You have to know how much of one unit there is in the other unit. So if you look at this problem I have here, 25 centimeters equals how many inches? Some of you may know this, some of you may not. That's okay. 1 inch is equal to 2.54 centimeters. Okay. Now, what's really cool, if we do a little algebra to this, something that's totally allowed is let's divide each side by 2.54 centimeters and divide by 2.54 centimeters. When we do that, everything cancels and this whole side becomes 1. So this is mathematically equal to 1. I know it looks a little strange. Numerically, it's not equal to 1. That's okay. But because we have units, these are actually quantities. They're not just numbers. These are a quantity. These two quantities are the same. And so they're equal. So if I multiplied a number by this quantity, then believe it or not, all I'm doing is really multiplying by 1. And because of that, what ends up happening is I can change the units, and that's without changing the quantity. This is the beautiful thing about dimensional analysis. So I'm going to erase all this, okay? And then I'm going to do this little problem here that I have set up. I'm going to actually end up doing both of them, and so that we can talk about this. All right, so here's the first one. So we got 25 centimeters equals how many inches? Whenever you start this, start with the given. So the given is whatever quantity they give you. So that's the given. Start with that. Now, what we're going to have to do is we're going to multiply by our conversion factor, right? Remember, our conversion factor is 1 inch is equal to 2.54 centimeters, all right? So if I want inches to be my end product, okay, so when we get an answer here, I want the unit to be inches. I want centimeters to go away. Where would I put, so the question is, where do I put centimeters in this conversion factor so that they will cancel with what I have right here? Do I put them on the bottom or do I put them on the top? I'm sorry, my pen's not working the best, but there you go. So the answer is you put them on the bottom, because the centimeters over here are actually, that's the same thing as centimeters over 1. That's the top of a fraction. So this is 2.54 centimeters there. We would put the 1 inch up here, 1 inch. Okay. And what ends up happening is the centimeters cancel. Remember, this is 25. That's not supposed to be 2.5, 25. And so now all we have is 25 times 1 divided by 2.54. Of course, mathematically, this is the same as 25 divided by 2.54. When you punch this into your calculator spits out 9.842525. Hold on, I'm going to erase my inches here. Rewrite this real quick. 25197. I don't know why my pen is not working again, but it's not working right now, so I apologize for that. And this is, of course, inches. Inches. All right. Now, here's the issue with this. We know that everything has to be sig figs. Your calculator doesn't have a brain, so you have to round everything to sig figs. Well, to round to sig figs, we do not count sig figs with our conversion factor. Don't worry about the conversion factor for counting sig figs. It's not worth it. It's not going to get you anywhere. Okay, we pretend that they're exactly precise, So they have infinity sig figs, so they don't matter. All right. So what matters is your given. Okay. So what does your given have? And like I said, my pen is glitching on me here. So again, I'm sorry about that. So how many sig figs do I have here? The answer is 2. So how many sig figs can my answer have? Answer 2. So this has to become 9.8 inches. Okay. And then circle or square the answer you want me to grade. Okay. So that's how you would do that problem. All right. Let's see how we would tackle this bottom problem here. Okay. Again, we need a conversion factor. So if we have any runners in the group, all the runners probably know how many meters 1 mile is. That's 4 laps on a track that's 1,600 meters, or 1.6 kilometers is equal to 1 mile. All right. So again, start with the given. All right. Our given is here. So 5 kilometers times 1 mile over 1.6 kilometers. And we put the kilometers on the bottom, of course, so they will cancel. If this had been miles instead, this would have been flip-flopped. Okay, those would have been flip-flopped there, because we would have needed to cancel the miles and not the kilometers. So just kind of look at what your units give you, and that's where it determines where it goes. So then we take 5K and we divide by 1.6, and we end up with, your calculator spits out 3.125. Sorry, that's my daughter. She's fussing a little bit, so I'm going to try to get done real quick before she gets too fussy. Again, we got to look at sig figs. We got 1 sig fig there, so I'm allowed to have 1 sig fig. So this would actually be 3 miles is what we'd have to round that to get to 1 sig fig. All right, that's a rudimentary look at dimensional analysis. There's a